RBS Digital Research Academy welcomes to you in the lecture number 5. The topic of this lecture is formative latent variable. Dear viewers, we will talk about the measurement models. The measurement model fall into the two categories. One is the reflective latent variable, and another is the formative latent variable. My video is available on the reflective latent variable. If you have a time, you can watch it, and then if you will watch this one, then I hope that you will clearly understand the difference between these two types of the latent variable. So this video is about the formative latent variable. So this is one image which is about the formative latent variable. So my name is Dr. Raimbat Sumru, and I'm from the Shabati University. This is my fifth theoretical video. I want to work on the SmartPLS. Before starting practical work on the SmartPLS, it is most necessary for us that we should understand the concepts of the SmartPLS, as we can know that means what we are doing into the SmartPLS when we will do the practically, and how the things are being done by you. Dear viewers, I'm pleased to share with you that I have completed the 9 modules of the SmartPLS Academy, and this is a certificate which was awarded from this Academy. Now, elements. So now this model I have discussed in the quite detail in the lecture number 4. But again, to repeat certain things, I have included this one into this model. So in this model, basically there are about the reflective model and the formative model. This is the structural model. So now, let me say, right now we are discussing about the formative model, and in the formative model, again, we have to check the impact of this indicator on this dependent variable, and then impact of this one on this one. And in this way, whatever the indicators are available, we have to check the individually the impact of each indicator on the dependent variable. So now these are the indicators, and then whatever the impact is there from the X21 to the Y2, this impact we call as a outer weights in the formative latent variable, and the same type of the like in the reflective manner, like the same like the weight is impact is there. With that impact we call as a loading. So this is a small little introduction of this model which we use now. Again, this model is basically primarily classified into the measurement model and the structural model. So for the structural model, my video is available on my YouTube channel. Please watch it. This is the one type of the like the satisfaction with the whole, and it has 2 constructs. One construct is a formative, and another is a reflective construct. So now a few things I want to discuss. In the reflective term, almost all the items we are asking the same thing from the respondent, but in the different words. Because of any reason, if this type of this one indicator is being deleted because of any reason, then it has no any significant meaning on the overall construct. It has no any problem. And on the other side, formative, here seeing that the different indicators are there. All the indicators, they are basically computing the different, are measuring the different type of the like the expect with the satisfaction in your hotel. Now see that each indicator is measuring the different aspect of the satisfaction. Because deletion of the item is a big problem for the formative construct, and it's not a big problem for the reflective construct. One of the problem normally researchers they are doing that now they are applying the measuring tools of the reflective on the formative, or sometimes they are applying the measuring tools of the formative on the reflective. This is the incorrect approach. Now, because the measuring tool for the reflective measurement are different from the formative and vice versa, and then formative indicators are assumed to be error-free. There is no any error on that one. So which means that the internal consistency reliability concept is not appropriate. So in this situation, the reliability, like we check through the Coron alpha. So now there is no need to check the reliability of the formative construct because these are error-free. So that's why there's no need to compute the reliability. And then Then we are required also to compute the validity. So now the validity we divide into the convergent validity and the discriminant validity. These are two types of the validities are there, and the using those associated with the reflective measurement model is not meaningful when the formative indicators are there and their weights are involved. So now the assessing convergent and discriminant validity using the criteria similar to those associated with the reflective measure model is not meaningful. A notion of especially whole for PLS-SEM, which assume that the formative indicator fully capture the contained domain. Now the contained domain, like in the previous slide, you saw that there were the two types of the construct, formative and the reflective. So now formative was that means that the construct was about the satisfaction with the hotel. So now different items were there, different indicators were there, all the indicators, so they were completely capturing the whole domain. Now domain is your hotel satisfaction. And then historical evolution criteria for reflective measurement cannot be directly applied or transferred to the formative and the vice versa. So now you have to be careful while you are applying the statistical evolution criteria on formative and as well as on the reflective measurement models. Okay, and then construct is dividend cause and do not necessarily correlate high, because formative normally there is no any high correlation. Sometimes there is a correlation, sometimes there is zero correlation, and sometimes the correlation is there, but that's a negative correlation. So it's not necessary all the time there should be the a good level of the correlation among the indicators of the formative. So that's why. Another reason is that the constructs independent cause, then every indicator is causing independently from another one. Like in case of the reflective, one indicator is highly correlated with the another one, but this is not the case in case of the your formative, where each construct, item of each construct is independent. And then instead of now, because of that one, the researchers should focus on establishing content validity. That's why researchers should focus on to validate the content of that one, the content of the formatively measured constructs. Now, here this is the evolution of measurement model. In the already I have discussed in the measurement model, two are reflective, and these are the tools to measure reflective. There are the 4 tools are there for the formative. There are the 3 tools now: convergent, validity, collinearity, and significance. Now see, some of the differences are there. The tools of the formative measurement model are somewhat different from the reflective and the vice versa. And the 6th one is evolution of the structural model. And my video is available on the evolution of structural model on my YouTube channel. Dear viewers, this is the guideline for these are the 3 steps are there. Step 1, we have to assess a convergent validity of formative. Step 2, we have to assess the collinearity issues in the formative latent variable, and lastly we have to understand the significance and relevance of the formative indicators. So this graph are the image I have taken from this book from its page number 121. This is the first step. In the first step, we have to talk about the convergent validity. Basically, discriminant and the convergent validity are the 2 types of the aspect of the validity. Construct validity. When we talk about the construct validity or to validate your construct, then 2 things are there: convergent and the discriminant your validity. So now discriminant means the validity talks about how your one construct is different from the other construct. Okay, and the construct validity means that a test designed to measure the particular construct, actually measuring the construct or not. Now, construct validity means that for example, one construct is your intelligence. You want to measure intelligence of a child, of your student. How to measure? Definitely, you have to provide some of the indicators over there. So are you sure all these indicators are actually measuring the intelligence of your respondent or not? So if they are actually measuring the same thing, so this is that means your construct is validated. For example, Here our construct is personality. So now in the person, there are the five our indicators are there. Now see from here, are you sure that all these like the openness and your consciousness, neuroticism, and the two others, that either they are measuring the personality or not. If they are measuring the personality, that means the construct validity has been intacted. If not, then the construct is not validated. It's not a valid one. And another thing is the first step on assessing the empirical PLS-SEM result is a formative measurement model. So in this one, the first step is what? That we have to measure the convergent validity. Now, what is convergent validity? Now, test that the construct that are expected to be rated are in fact rated. Now, the construct that are expected, that means you expect that these constructs are related. Do you think that are you sure these are related with each other or not? And then another meaning is that the extent to what, up to what level the measure correlates positively with the other. Now the one measure up to what level that is correlated with the measure of another construct. Now another construct may be a reflective, may be a formative. If it is a reflective construct, then the measure of the same construct using the different indicators. Is there any like the relationship between the like the indicator of the first order construct with the indicator of the second order construct? Now, first and second order construct, like now these are personality construct. So these are its first order construct. These five are its first order construct. Now, definitely this open has a certain other like the indicators are there. So now, do you think if there is a high correlation between this construct with the any item of the second level construct? So now it means that the convergent validity is not intact, has not been established. So hence, when the evaluating formative construct measurement models, we have to test whether the formative measured construct is highly correlated with the reflective of the same construct or not. If there is a high correlation between these two ones, then there is a problem. This problem we call is a redundancy analysis. So redundancy means the useless. So now the term redundancy analysis stems from the information in the model. Okay, model being redundant in the sense that it is included in the formative construct, again in the reflective. Then the same indicator is available into your formative as well as into the reflective. So now both are same. That means that now these two items have become, our indicator have become redundant, have become useless because of the high correlation between these two indicators are items of the two first level construct and the second level construct. So now, what is the solution of this one? The one solution is that the furthermore establish the reflective measurement model instrument may not be available. Sometimes what we have not available the reflective measurement model, which is as established. Established means that since the several years we are using that reflective measurement model. For example, service quality model. So these are the model which are since the several years we are using, and their reliability and their validity is well established. So that's why there is no question of the validity and reliability. That's why we call these measurement instrument is a established measurement instruments. So now, if that is not available, reflective is not available, then we the solution of this problem is about to develop a global item, a one item. Now compare this one. This is a one item. Please assess the extent to which the company XYZ, whatever the company, acts in socially conscious way. Now it's like the scale is from 0, not at all, and to 1, definitely. So this is the one question. Okay. And alternatively, there are these other questions are there. Now this is our reflective. Now all these items are talking about the same thing. So now if you can put this one question globally, a global item, or you can put this one. Now almost the result will be same if you compare. In order to check the assess the convertibility, now you may keep the one global item, or you can keep several items over there of this one construct. So now almost the result will be same. How? Then Now, here it is our example, formative measurement model. Now, here this is a formative, and this is a global single item for the CSR. Now, in comparing these are different, several items are there of the CSR, but here is only one. Now, the relationship between these two one is about the 0.857. Now, this is the higher than this requirement. Now, if the path coefficient between the relationship between the formative measurement model and this global single item, if the relation is more than or equal to say 0.7 or more than 0.7, so now that means the convergent validity has been established well. This is the SmartPLS model is there, simple model is there, where these are the different items are there, and we want to check and pick relationship between these. So now this relationship is its value is higher than the 0.7. So now its convergent validity has been here established successfully. Now, here another thing is that should we use multi-item measure or global single item? We have to compare these two one. And validating formative specification of the service value measure. Now here these are the number of the observations are the sample size. And if there is a 100 sample size, the global single items result is a 0.77. It's somewhat higher than the 0.7. And if the multi items are there, we'll see all are the higher than this 0.7, and almost all are the same if the sample size is 100. But if you increase your sample size, then probably it may happen that the value is there, which may come down 0.7. So that's why the solution of this problem is that the threshold or 0.7 provides only a rough guidance. This is a rule of thumb. This is a rough guidance because we are dealing in the social science, and the social science most of the time we have the rough guidance of the rule of thumbs. Now, if your sample size is increasing, then even it is possible you can come down from this level of 0.7 to 0.6. It means that you may come down from the 70% to 60% if your sample size is higher. For example, consider lower threshold for this higher sample size and the very abstract constraint. That means that those constraints which are highly abstract. So now, if in these two cases, then you can reduce this threshold from the 0.7 to 0.6 even though. Assessing the formative measurement model collinearity. Quality is a very big issue. In the formative, basically you should keep in your mind that in the formative items, high correlation is not accepted. There should not be high correlation among the indicators of the formative model or formative latent model. The reason is that all the indicators of the formative, they are basically measuring the different aspects of that thing. For example, if you remember the few slides back, the example of the hotel. So satisfaction with the hotel. So on the other side, on the formative side, all the indicators were there. All the indicators, they were measuring different aspects of that satisfaction. So now high correlation is not required over. Then collinearity occurs between the two indicators. Now, what is collinearity? When there is a high correlation between the two indicators, that is called the collinearity. And when there is a high indicator more than high collinearity more than two indicators, this is called the multicollinearity. Okay, either there's a collinearity or there's a multi, but it's a big issue. Now, collinearity. If there is a collinearity in your data, now what will happen? It will boost the standard error unnecessarily. It will exaggerate the value of standard error. And then another problem will be there. It biases indicators weights. I think you know about the difference between the loading and the weights. In case of the formative, we use the same thing as a weight. In case of the formative, we use as a loading. So now what will happen? It biases the indicators weights. So now these are the weights. These are the weights. So now what will happen? That these will be biased. And another issue will be there that even that sign will be changed. Now this is the positive, and now its sign has been changed. It's become negative. So now these are the reasons of the high correlation among the multicollinearity between the two indicators of the formative. Now see here, X1. Okay, X2 and the X1. So now the relationship between these two one is a 0.6 68. That means a 68% there is a correlation between the X1 and X2. That's why I see that the sign of this indicator has been changed. Now, well, X1 and the Y1, there's indicator of 0.38. So that's why the sign has not been changed. So these are the results of the high correlation between your two indicators of the formative latent model. How to understand that either the multicollinearity or collinearity occurs in your data, in your model or not? Simple solution of this one is the values of the variance inflation factor. That means that if there's a high correlation, that the variance of the inflation factor will be unnecessarily inflated. Now, for example, the balloon is there in which you are injecting some air. So now its size will be unnecessarily will become large. So the same thing is there when there's a high quality, the variance inflection or VIF, its value will be increased. The concept regress, what is the concept of the VIF? Now basically we have to regress all indicators with the formative measurement model. Now the formula of this one, the VIF 1 over, that means 1 minus R square. So now here, how to regress? These are our 5 items. Now these are 5 items, our indicators are there, all have been regressed with the CSR1. Okay, and then this is the value of the R square, and when we convert it, it becomes a 1.56. Now this 1.56 is quite low. Even if less than 3, then you must be sure that there is no any issue of the multicollinearity or collinearity in your data. And these are the VIF of all 5 indicators. Like these 5 indicators are the same indicators are here. Now you can check that all the values are quite low, and these are within the range of the 3. So now that means at least in this model there is no any collinearity. So now collinearity we can check with the help of the VIF, variance inflation factor. Now, this is the one type of the guideline for us. Now, first thing is to assess the level of the collinearity. Okay, no critical level of the collinearity if the VIF is less than 5. If this is the case with your model, with your formative model only, then there is no any problem, and you can go ahead without any problem. But if the critical value, okay, that's higher than 5, equal to 5 or higher than the 5, then this model is carrying some type of the collinearity. There is a collinearity issue is there. Now, 2 solutions are there. One solution is that no critical level of the collinearity and VIF is less than 5. Then what we should do to analyze the significance of outer weight, interpret them, and the formative indicators also. No problem is there. Now, and then if the critical value is higher than 5, the only solution of this problem is to delete that indicator, because there is a high correlation between this indicator and another indicator. So either you are required to delete any one indicator, or if possible, then you can collect more data. So now in this way, you may be able to solve the problem of the collinearity from your formative measurement model. Assess significance and relevance of formative indicator. How to assess? Does the formative indicator truly contributing to the forming construct? Are you sure that the construct indicators of that in construct are truly contribute in that construct or not? For example, here is a personality construct. So in the personality construct, different indicators are there. Are you sure all these indicators, they are sufficiently contributing in this construct, formative construct, and that this formative construct is with personality? That means they are contributing in varying the personality of the respondent or not. In this one, to answer this question, we must test if the outer weights. Now here, if the outer weights in the formative measurement and the loadings in the refractory measurement models are significantly different from the 0 or not. If they are significantly different from the 0, that's one. Now this we can know through with the help of the bootstrapping procedure. And then with this information, T values we use to calculate it to check out the significance of those weights. Either those weights are statistically significant or not. This we can check with the help of the T values. And then the weights represent the indicators' relative contribution considering all indicators in the set. Now, each weight is telling you the how much the indicators contribution is, relative contribution is in the model. Weight should be significant, use bootstrapping. Okay, problem average weights, and we can check the average of this one divided by the 1 over number of the indicators and their square root. Loadings represent the indicator's absolute contribution. Okay, each loading is representing the each indicator's absolute contribution in the model. That is the information an indicator provided without considering other indicator. So this information is being provided by the every indicator by not considering the contribution of the other indicator of that same model. And then again, another guideline is the outer weight significant testing. Now, outer weight is significant, then what? Continue with the interpretation and do all these things and go ahead. But if the outer weight is not significant, then what to do? Analyze the formative indicators, outer model, outer loading, and then the outer loading, if it is a less than 0.5, if it is a less than 5.5, then what to do? Test the significance of the formative indicators outer loading, and then the outer loading in the less than 0.5 and non-significant. That means that on one hand, the value of outer loading is less than 0.5, and on the other, if it's not statistically significant, then consider to delete that indicator from the formative model. On the other hand, if the outer loading is less than 0.5, but it's significant, then you can consider to remove it at other time at advanced level. It's also possible. And if the outloadings are greater than 0.5 or equal to 0.5, then you can keep it. And even if it's not significant, no problem. Okay, now 0.5 means that there's contribution. If their contribution, its contribution is more than 0.5 means 50%. If there is contribution is the more than 0.5 or 60%, 70%, then keep it in the model, even though it is not statistically significant, no problem. Dear viewers, this whole chapter, that is the reflective formative, I have developed by going through this book. Actually, in this book, there are two chapters are there. One is on the formative, and another is on the reflective. If you find time, you can go through to read these two chapters from this book. And if you require this book from me free of the cost, then you can send your email on this one, and free of cost, I will provide you the same book, like the soft copy of this same. At the end, thank you very much for your time.